The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to go on and take a look at a Chapter 4 test in a way of reviewing for the final exam. Just a reminder, tomorrow we'll go over Chapter 5. Your final exam is on Monday. Next week, there are no classes other than just you take your final Monday by 11:59 p.m. Monday night. There'll be no class meeting or office hour or anything. As far as your grades go, as soon as I have everybody's grades calculated and entered in, I will email each person individually with your grade. So don't bother sending me emails saying, what's my grade? Where is it? Blah, blah, blah. I will send them out when they are ready. And for the 3 people that are actually watching this later on, you'll know. Okay. So we're going to work on problem number 1 over here in WebAssign, solve the system by graphing. So I'm going to bring up a graph here. And let's take a look. It says y equals 2x minus 7. So y equals 2x minus 7. And then x minus 2y equals -4. Now, the graph that I'm using only goes from -6 to 6 and -6 to 6. And I could use the other graph, but it gets more complicated going back and forth anyway. So I have to be careful what values I choose to make sure that they lie within this graph. So what I'm going to do is I'm going to let x equal 1. And then we get y equals 2 times 1 minus 7, which is 2 minus 7 or -5. And then I'm going to let x equal 2. When x is 2, y equals 2 times 2 minus 7, which is 4 minus 7 or -3. So when x is 1, y is -5. Let's see, that would be right there. When x is 2, y is -3, which is right there. So let's see, graphing that line. Okay, let's see here. All right, so there's the graph of y equals 2x minus 7. Then let's take x minus 2y equals -4. And let's see here. I'm going to let y equal 0. And then I get x minus 2 times 0 equals -4. X minus 0 equals -4. X equals -4. And then I'm going to let x equal 0. So I get 0 minus 2y equals -4. -2y equals -4. Divide both sides by -2y equals 2. Let's see, -4, 0 is here, and 0, 2 is there. Let's see here. It's tricky to get this all lined up. Let's see here. Well, it looks like they intersect at 6, 5. I can check that by taking this ordered pair and plugging it into both of the original equations. So let's see. If x is 6 and y is 5, in the first equation, we'd have this. 5 equals 12 minus 7. 5 equals 5. So it checks in that equation. Second equation, x minus 2y equals -4. 6 minus 2 times 5 equals -4. 6 minus 10 equals -4. -4 equals -4. So it checks. All right. So I'm going to put in 6, comma, space 5, and let's see what happens. And we're off and running. Okay, let's take a look at problem number 2. Same thing, solve the system by graphing. So we've got x plus y equals 3, x plus y equals 3, and y equals negative x. I'm going to go ahead and use the x and y intercepts for this first one. If y is 0, I get x plus 0 equals 3, or x equals 3. If x is 0, I get 0 plus y equals 3, or y equals 3. So 3 comma 0, 0 comma 3. Let's see here. Okay. So there's the first one. X equals, or y equals negative x. Oh, how about this? Let's let x equal 0 and then 1. If x is 0, y equals negative 0, y equals 0. That's why I didn't go after the other intercept, because it goes through the origin. And if x is 1, y equals negative 1. So 0, 0, 1, negative 1. So what do we have there? Parallel lines. So that is going to be no solution. So no solution. Okay. All righty. Yeah, get that clock out of here. Okay. Solve the system by substitution. There we go. Leftovers from yesterday. Okay. Let's see here. So we've got y equals x minus 1 and 3x plus y equals negative 9. Let's review the steps for substitution. First of all, solve one of the equations for one of the unknowns. Oh, and here I'll label this equation 1 and equation 2. Solve one of the equations for one of the unknowns. I'm going to take equation number 1 and let's solve it for y, since it already is solved. Okay. So then I'm going to substitute this in the place of y in the other original equation. This is going to give me 3x plus y, but now y is replaced with x minus 1 equals negative 9. If we've done this correctly, we should now have one equation with one variable, and we do. Solve for the variable, 3x plus x minus 1 equals negative 9. Combining like terms, 4x minus 1 equals negative 9. Add 1 to both sides, 4x equals negative 8. Divide both sides by 4, x equals negative 2. So because I got a variable equals a constant at that step, I know that I have a single ordered pair, a one-point solution. If I had gotten a false statement like 2 equals 3, that would mean there was no solution. If I'd gotten a true statement that was a number equals a number like 7 equals 7, that would mean that they are the same line and there's an infinite number of solutions. But since I got x equals negative 2, that means there is a single point solution. So now I'm going to take that and I'll put it in either of the original equations. I'll put it in the top equation, y equals negative 2 minus 2. So y equals negative 3. So now I think that's the solution. I'm going to check it in the other equation. 3 times negative 2 plus negative 3 equals negative 9. Negative 6 plus negative 3 equals negative 9. -9 equals -9, and so it checks. All right, so -2, comma, space, -3. Okay. Any questions there before we go on?
Nope.
Nope. All right. And another system of equations that we're going to use substitution on. 3x plus 18y equals -15. X plus 6y equals -5. And again, I'll call this equation 1, equation 2. I'm going to take the second equation and solve it for x by subtracting 6y from both sides of the equation. So x is equal to -6y minus 5. I'm going to take that result and replace x with it in the other equation. So now I've got 3 times x, but x is now that, plus 18y equals -15. If I've done this correctly, I should have one equation with one unknown, and I do. So we've got -18y minus 15 plus -18y equals -15. Combining like terms, I get that. Oh, so we don't have a single point of solution, but we do have a true statement. So that means they are the same line, just different forms of the same line. So there are infinitely many solutions. So we're going to put over here. And let's see here. Oh, infinitely many.
Yeah.
Yeah, and it's picky. You have to spell it right. I had to chuckle on one of the tests where people were supposed to spell it and they spelled it incorrectly and it marked it wrong, but I still gave them credit, but I thought, you got to pay attention. Okay, so let's see what happens. All right. Solve the system using elimination.
Oh, nice.
All righty then, you betcha. So here we have what, number 5, elimination. 3x minus y equals 7. 2x plus y equals 8. Well, you really couldn't ask for a better setup because it's already set up that where if you add the two equations, the y's disappear. How nice is that, right? Then dividing both sides by 5, x equals 3. So now I'm going to plug that into either one of the originals. I'll plug it into the top. 3 times 3 minus y equals 7. 9 minus y equals 7. Subtract 9 from both sides. Negative y equals -2. Divide both sides by -1. Y equals 2. So I get x is 3, y is 2, or 3, 2. And I'm going to check that in the other equation. 2 times 3 plus 2 equals 8. 6 plus 2 equals 8. 8 equals 8. Ka-ching. Okay. So 3, 2. 3, comma, space 2. And submit the answer. All righty. Any questions there?
Nope.
Another mistake I've seen people make is they'll put parentheses in the box when there's already parentheses included. So I know you folks get stressed during a test, but try to pay attention to what's already there. Okay. 6, solve the system using substitution or elimination. Okay, so we've got 3x minus 5y, minus 17 equals 0. And then we've got x over 2 minus 5/6 y equals 1/3. Well, the first thing I'm going to do is I'm going to take that second equation and I'm going to clear the fractions. So I multiply both sides of the equation by the least common denominator, which would be 6. So that gives me 6 times x over 2 minus 6 times 5 6y equals 6 times 1/3. 6 over 2 is 3 over 1, so I get 3x. 6 over 6 is 1, so minus 5y equals 6 over 3 is 2. Okay. All right, now, very interesting. So I'm going to take the top equation and I'm going to add 17 to both sides. So I get 3x minus 5y equals 17. What I noticed was this. I'm going to take the bottom equation and multiply both sides by -1. So I get negative 3x plus 5y equals -2. Okay. Now, why did I do that? I'm going to take this top equation and this bottom equation. By the way, I'm using the elimination method. And I'm going to add them together and I get this, which is a false statement, so no solution. Okay, you follow all that?
Yes.
All right. Oh. Oops, I can't spell. No, I can't type. I need to leave a space in there, I think. All right, on to the story problems, everyone's favorite part.
Not entirely.
Maybe not everyone's, okay. All right, number 7. Use 2 equations in 2 variables to solve the problem. Rectangular shaped dance floor has a perimeter of 162 feet. If the floor were 21 feet wider, its width would be equal to its length. Find the length and width of the dance floor. All right. How about if we call the length L and the width W? All right. Well, it talks about the perimeter of a rectangular shaped floor. So we've got this rectangular shape, length and width. The perimeter would be 2 times the length plus 2 times the width, right? But we're told that the perimeter is 162 feet. So 162 equals 2 times the length plus 2 times the width. There's one of our equations. All right. Then it says if the floor were 21 feet wider, its width would equal its length. So if we take the width plus 21 feet, we get the length. Make sure you follow where I got that. If the floor was 21 feet wider, so if we add 21 feet to the width, it's equal to the length. Are you okay with that?
Yes, I am.
So there's our second equation. I think we should use substitution because the second equation is already solved for L. Okay. So I'm going to take this and put it in the place of L in the other equation, giving me 162 equals 2 times L, which we're replacing or substituting with W plus 21 plus 2W. If we've done that correctly, that should produce one equation with one unknown. Time thing keeps popping up. 162 equals 2W plus 42 plus 2W. Combining like terms, 4W plus 42. Subtract 42, 120 equals 4W. Divide by 4W equals 30. Well, let's see. Let's take that and plug it into either one of the original equations. Let's put it in here. If W is 30, we get 30 plus 21 equals L. So 51 equals L. If that's true, let's check that in here. We get 162 equals 2 times L plus 2 times W. 162 equals 102 plus 60, which is 162. So it checks. So we've got 51 and 30 the length is what, 51 feet. And the width is 30 feet.
Mhm.
All righty. Let's go on to problem number 8. A woman invested some money at 8% and some at 9% annual simple interest. The interest for 1 year on the combined investment is investment of $10,000 was $830. How much was invested at each rate? Okay, so we've got 2 investments. Let's see. I equals P times R times T. And let's see, we've got some at 8% and some at 9%. So I'm going to call this at 8% and this at 9%. So woman invested some money at 8% and some at 9%. So this interest rate is 8% and this interest rate is 9%. For 1 year, let's see the interest, combined investment of $10,000. Okay, so they've got $10,000 to invest. If they invest part at 8%, we'll call that part X.
Mhm.
The total's 10,000 and they invest part at 8%. What have they got left? 10,000 minus X.
Minus.
Okay.
Mhm.
Let's see here now. So the interest for the 8% would be X times 0.08 times 1, which would be 0.08X. The interest at 9% would be 10,000 minus X times, 0.09 times 1. See if I can get this in here. Times 10,000 minus X. All right, and what else do we know? We know that the total interest is $830. So basically, I can't talk today. Our equation is this: 0.08x plus 0.09 times the quantity 10,000 minus X equals 830. Okay, any questions about that?
My question is, can we set it up as 0.09 and then the parentheses X minus 10,000? Or does it matter?
No, let's take a look at that. I just threw away my $10,000 in the garbage. Let me get it back out. Okay. Together it's $10,000, right?
Yes.
So if I call the 8% X, what have I done? I've taken 10,000 minus X. Okay.
Okay. That's why I wanted to
10,000
know.
minus X is not equal to X minus 10,000.
Okay.
You see that?
Okay.
Yeah, that's a mistake people make. I'm going to put my $10,000 back in the garbage. Okay, so I'm going to multiply both sides of this equation by 100. You know what? I just realized something. I did this problem using chapter 2. I'm supposed to use 2 variables. Okay, so I'm going to have to fix this. My bad. It works this way, but this is the way we do it in chapter 2 before we've gotten into this 2 variables, 2 unknowns. So hang on here. I didn't follow the directions. See, I knew that as soon as I started talking about it, if people would just pay attention, that I would be the one that screws up. It never fails. All right.
Okay.
This. All right, now let's see if I can fix this. So we're going to call that Y.
Okay.
Yeah. Okay. What you're going to see, you're going to go, oh, well, that's the same thing. What are our two equations? One of them is x plus y equals $10,000.
Okay.
And the other one is 0.08x plus 0.09y equals 830. Okay.
Yes.
Now, watch. Let's take the top equation. Let's use a substitution, and let's take the top equation, so equation number 1,
Mhm.
and solve it for y. Okay. So x plus y equals 10,000. I'm going to subtract x from both sides. Y equals 10,000 minus x. Okay. With me so far?
Yes.
Let's take all of this and replace y in this equation. And what do we get? Well, you look at that. You see, that's the equation I had doing it the other. Maybe it was good that I made that mistake. So can you see how the two are related? See how? So
Yes.
basically using two equations, two unknowns gets us to the same place. Okay. So now we're going to multiply both sides of this equation by
100.
By 100. Yes, like you said. So here, here, and here. Okay. So I'm going to get 100 times 0.08x plus 100 times 0.09 times 10,000 minus x equals 83000. Okay. 100 times 0.08x is 8x. 100 times 0.09 is 9, and that's times 10,000 minus x equals 83,000. Okay.
Mhm.
Which is, let's go to the next page here. Okay, so I've got 8x plus 9 times 10,000 minus x equals 83,000. Okay, so 8x plus 90,000 minus 9x equals 83,000. Combining like terms, negative x plus 90,000 equals 83,000. Subtract 90,000 from both sides of the equation. Negative x equals, what's that going to be? Negative 7,000. So x equals 7,000, dividing both sides by negative 1. All right, so if x equals 7,000, let's see, x plus y equals 10,000. So if x plus y equals 10,000, we'd have 7,000 plus y equals 10,000. Subtract 7,000 from both sides, y equals 3,000. Okay, so we get this. Let's check that in the other equation, which is, let's see, 0.08x. So 0.08x plus 0.09y equals 830. Well, let's see, calculator time. Okay, if we take 0.08 times 7,000, we get 560. And if we take 0.09 times 3,000, we get 270. And 270 plus 560, let's hope it equals, and it does, 830. So, okay. Now let's make sure we've got the right numbers. X was 8%, and X is $7,000. Again, you don't want to get the answers mixed up.
Mm-mm.
Y was 9%, which was $3,000. And here we go. All righty. Okay. Yeah, so again, back in chapter 2, we could have done this problem the way I did it at first and just put my brain in neutral and slid right through it. But it said 2 equations and 2 variables. Okay. A custodian is going to mix a 4% ammonia solution and a 12% ammonia solution to get 1 gallon, 128 fluid ounces of a 7% ammonia solution. How many fluid ounces of the 4% solution and the 12% solution should be used? Okay, so I like to set mixture problems up like this. So it's like we've got these 2 beakers. In fact, when I'm in a classroom, I actually pick up some beakers or something and show pouring them together. But, well, here's our 2 beakers, okay?
All right.
Pour them together. All right, Bob and Larry there. Okay. A custodian is going to mix a 4% ammonia solution. So this will be the 4% solution. And a 12% ammonia solution, 12%, to get a 7% ammonia solution. How many fluid ounces of the 4% and 12%? Okay, so we're going to use 2 equations and 2 variables. We're going to call this X and this Y. And this is going to be 128 fluid ounces. Okay. So our first equation is that X plus Y equals 128. Our second equation is that 4% of X plus 12% of Y equals 7% of 128. All right. Let's see. I'm going to go ahead and multiply the bottom equation by 100 to get rid of the decimals.
Sorry.
That's all right. So we get 100 times 0.04x plus 100 times 0.12y equals 100 times 0.07 times 128. So I get 4x plus 12y equals 7 times 128. And let's see what that is. 7 times 128 is 896. So 4x plus 12y equals 896. All right, I'm going to take these 2 equations now and go to the next page and take it from there. Okay, so X plus Y is 128. And then 4x plus 12y, 4x plus 12y is at 896. Okay, I think I'm going to use substitution again. I'm going to take the top equation and we'll solve it for y. So let's see, x plus y equals 128. Subtract x from both sides, y equals 128 minus x. That's going to go in the place of y in the other original equation. Okay. 4x plus 12 times 128 minus x equals 896. Here's our one equation, one unknown. 4x plus, let's see here, 12 times 128 is 1536 minus 12x equals 896. Combining like terms, negative 8x plus 1536 equals 896. Subtract 1536 from both sides. Let's see. We get negative 640. Divide both sides by negative 8. And we get x equals 80. Okay. I'm going to plug that into either of the originals. I'll plug it into that. 80 plus y equals 128. Subtract 80, y equals 48. check that in this other equation. 4 times x plus 12 times y equals 896. 320 plus, let's see here, 12 times 48 is 576. 576 plus 320, and it checks. So x is 80, y is 48, and x was our 4% solution. So the 4% solution should be 80 ounces, and the 12% solution was y should be 48 ounces.
Mhm.
All righty, one more to go. So here is number 10. Write a system of 2 equations and 2 variables to solve the problem. Flying with a tailwind, a pilot flew an airplane 900 miles in 4.5 hours. So that's with the wind. The wind is blowing at the airplane's tail, so it's going with it. Flying into a headwind, that's against it. The return trip took 5 hours. Find the speed of the plane in calm air and the speed of the wind. All right, let's do this. Let speed of plane equal x, and let speed of wind equal y. Okay, so we've got our table here. Let's see here. Distance equals rate times time.
Mhm.
And we've got into wind. Oh, let's see. It gave the tailwind first, I guess. So we should do that. Okay. Doesn't really matter, but maybe I'll be less likely to make mistakes if I do it that way. Okay. So tailwind, so with wind. And then headwind against. Can't spell against wind. All right. Flying with a tailwind, a pilot flew an airplane 900 miles in 4.5 hours. Flying into a headwind, so against the wind, the return trip, which would be the same distance, took 5 hours. Okay. Now, the rate, the speed of the plane in still air, I should say this is in still air. So in other words, there's no wind, calm air, they say, in calm air. Okay. So going with the wind, you've got the speed of the plane in calm air, plus the wind is helping it along. Okay.
Mhm.
Going against the wind, you've got the speed of the plane minus the wind, so the wind is hurting it.
Mhm.
So now your 2 equations become this. 900 equals 4.5 times the quantity x plus y. And I could have written it x plus y times 4.5, but anyway, just like it better this way. And then 900 equals 5 times x minus y. Okay, so there's your 2 equations. Well, now the thing that immediately jumps out at me is that x plus y, x minus y. If we could add those together, the y's would cancel. So I need to get rid of those coefficients. So I'm going to take the top equation and divide both sides by 4.5. Okay, so I've got 900 divided by 4.5. So I get 200 equals x plus y. Okay. Bottom equation, I'm going to divide both sides by 5. 900 divided by 5 is 180 equals x minus y. So this gives me 380 equals 2x. See how nicely that all worked out?
Mhm.
Divide both sides by 2, x equals 190. Okay. Well, if x equals 190, let's plug that up here. 200 equals 190 plus y, subtract 190, y equals 10. Let's check it in the other equation. 180 equals 190 minus 10. That's true as well. So it checks. So the speed of the plane in still water or still air is x. So that's 190. And the speed of the wind is 10 miles per hour. Well, let's see if I get it all correct. Yay, I'll be able to sleep tonight. All right. And I've got 23 minutes and 5 seconds left to go. Thanks, but no thanks. All right. So again, let's see here. Tomorrow, I'll be back at 10:30 to do chapter 5. I'll be back this afternoon at 1:15, as well as tomorrow at 1:15 with office hours. Monday, no class meeting. You take your final. When I've got them done, I will email the results to each person in the class. All righty, I'm going to stop the recording.